channel. My name is Anayati and today I'm going to talk about air conditioning system. Maybe you cannot imagine a car without air conditioning system, especially if you are living in a place with sultry or freezing climate. But until 1950s, all the cars in the world were produced without the system, and then some companies started to use AC system on some luxury models, and with more demand for better and more comfortable cars, the AC system turned into a standard equipment on automobiles. And today, luxury cars can provide different air conditions for different tastes of individuals that are sitting in different zones of that car. But do you think that this level of comfort is important and necessary? To answer this question, I should say that how much you take away stress from your body and mind, your output would be better. In other words, your concentration and reaction can be impaired by bad conditions and stress. And studies have shown that increase of temperature up to 35 degrees centigrade can impair your brain reasoning and performance about 20% due to thermal stress on your body. But what conditions for occupants of a car are considered to be comfortable regarding air quality? Studies have shown that an average person feels comfortable in temperature of 21 to 26 degrees centigrade and relative humidity of 45 to 50%. Also, your clothing, metabolism, and even your genetics can affect these comfortable conditions. But when you are sitting in a car, your comfort also depends on outside condition, flow rate and temperature of supply air, and of course, sun radiations. Even presence of odors and fumes can affect your comfort. Now, if we have an equipment that provides warm or cool dehumidified air and removes particles and odors from that, maybe we can provide these comfortable conditions. To accomplish this job, best choice is a substance with low boiling point that works in a system with fan, heat exchanger, ducts, and filters. To continue this discussion, I think I should present you some scientific facts. In simple words, I can say that liquids and gases can turn to each other if their temperature and pressure change to a certain point. A liquid can turn into a vapor if you add enough heat to that just when water boils into the vapor. And if you drop pressure of that liquid very, very low, it starts to absorb the surrounding heat and this vaporization happens too. Both of these state changes can happen in opposite direction. It means that by taking heat away from a vapor, it starts to turn into a liquid, and this process is known as condensation. And also, if you increase pressure of that vapor, it gets ready to dissipate heat to the outside, and this condensation happens too. Engineers use these laws and first and second law of thermodynamics to extract heat and adjust the humidity of car's interior. First law of thermodynamics states that total amount of energy in a process remains intact and energy only changes from one form to the other. And second law that is related to entropy states that natural flow of energy is always from hotter body to the colder. Now, I think it's sensible for you that if we have a system that works in a cycle to absorb the interior heat and dissipate that to the outside, we can make that interior cool. For this purpose, best choice is a substance with low boiling point that is in liquid state, but is very eager to turn into a vapor and evaporate that using interior heat energy in an evaporator by blowing air over that and receive cool air from the AC system. This substance that we use for this purpose is known as refrigerant. Now, keep this refrigerant definition in mind to talk about heating the interior. To heat up the interior that is not subject of this video, we can use hot coolant that comes out of the engine and guide that through a heat exchanger and blow air over that and receive warm air from the AC system. Of course, the heat energy that is provided by the heat exchanger can be produced by other ways like directly burning fuels or using electrical elements. Now I go back to that refrigerant. As I said, in AC systems, we need to use a refrigerant with low boiling point, and it means that in ambient pressure and temperature, this refrigerant is in gas state. So we know refrigerant as a gas. One of the first refrigerants that was used in mobile AC systems was CFC-12 or R12, that is known as a freon with boiling point of about minus 22 degrees Fahrenheit. But this R12 refrigerant had some major drawbacks. This gas is known to be an ozone depleting gas, and it means that chlorine content of this gas reacts with ozone gas in ozonosphere layer of the air under effect of UV rays and makes this layer weak over some areas of the earth. Also, this gas is known to have greenhouse effect that leads to global warming, and it means that presence of some gases like R12 and also carbon dioxide in the sky causes the sun rays that want to leave the earth after reflection reflect inside again, and this makes the atmosphere to get warmed up. These drawbacks made the R12 replaced with R134A or HFC-134A after 1994. R134A has the boiling point of about -16 degrees Fahrenheit and today is used in most of the mobile AC systems. And however, this gas is not an ozone depleting gas, but it makes a small contribution to global warming. But the United States and European governments are looking for refrigerant with less effect on global warming, and two candidates for this purpose are R744, that is pure carbon dioxide, and also R1234Y. I have plans to record a video about technical requirements and precautions for the systems that are using these refrigerants, and watching that video is highly recommended for those AC system technicians. Now, by using any of these refrigerants, we need to have a system that works in a cycle to inject these refrigerants into that, and by using an evaporator, extract the heat from interior and receive cool air from the AC system. This working system and cycle requires these main components: a compressor, a condenser, a filter-drier, a thermal expansion valve, and an evaporator. The refrigerant, after coming out of the evaporator, is sucked into the compressor. In fact, the compressor is the heart of the system and receives its power from the engine using a belt. There are different types of compressors, but all work based on the same principles. Refrigerant must be compressed, and for the systems that use R134A, pressure of the refrigerant increases from about 2 bars to about 16 bars. So the output of the compressor would be a gas with high temperature and high pressure. Now the gas is in a state that is ready for dissipating heat to turn into a high pressure liquid. This process happens inside the condenser that is just like a thin radiator. This high pressure liquid, after leaving the condenser, goes into a filter and dryer that is in form of a bottle or is integrated into the condenser. The dryer absorbs the moisture, and the filter, that is a small part of this component, filters particles that want to fly into the whole system and probably would damage the thermal expansion valve or the compressor. Here, you just remember that the output of the filter dryer is liquid refrigerant. Then refrigerant goes into the tubes to reach thermal expansion valve. In design of thermal expansion valve, engineers use rules of physics that state that when a fluid expands, its pressure drops. In the expansion valve, there is a very narrow passage that in one side there is a high pressure refrigerant, and on the other side there is an evaporator with low pressure. When the refrigerant passes this passage, its pressure drops and it turns into low pressure liquid, and in this pressure, refrigerant tends to be in gas state even in temperatures very lower than 32 degrees Fahrenheit. So it suddenly goes into freezing temperatures, and when warm air of the interior passes over the evaporator, cool air comes out of the AC system. The refrigerant, after coming out of the evaporator, goes toward the compressor, and this process continues as long as the compressor is on. Now that you know working cycle of the system, let's talk about working principles of each component. I start again with compressor. When the compressor comes on, it sucks refrigerant into a low pressure chamber. This low pressure chamber is formed by the movement of a piston or plate that is moving by rotation of a shaft that it turns by the torque that is applied by the engine power through a belt, or for electric or some hybrid cars by an electric brushless motor. When the shaft of compressor rotates, the piston or plate that caused the suction now tries to compress the refrigerant, and on the compression the inlet valve closes by a check valve. But the output valve can be opened at a pre-adjusted pressure. This adjustment of pressure is accomplished by using a spring-type steel plate for on and off type compressors that are known as fixed displacement compressors. To control switching of the on and off type compressors, there is a magnetic clutch that pulls and engages the rotating pulley with the input shaft of the compressor when you command the AC system to turn on, and some other requirements are satisfied that I talk about them in this video. On the modern compressors that are known as variable displacement ones, an ECU continually controls an electric valve to control the output of the compressor. I don't want to confuse you with more technicalities and details of these systems, but you just know that controlling these systems is just by controlling the compressor, whether it is on-off type or a modern variable displacement one. Now, after the compressor, we have the condenser. Input of condenser is high pressure and hot gases refrigerant, and its output is high pressure liquid refrigerant. So you can easily understand that what happens in the condenser. In simple words, we can say that using a fan, refrigerant dumps a large amount of its heat energy in the condenser. When you request for cool air by pressing AC switch, other than the magnet clutch of the compressor, ECU turns on the fan in front of the condenser. Almost always the condenser is located between the radiator and the grille in front of the car. A fan pushes or pulls air on the condenser, and this passing air absorbs the heat from that, and the phase changing happens for the refrigerant. In most of the AC designs, after the condenser, there is a filter dryer. This filter dryer is there to not let the moisture and particles to go into the system. To absorb the moisture, dryer uses desiccants, and its design is so that only liquid refrigerant can pass into the system. Next component is the thermal expansion valve that is located just before the evaporator. There are many designs for the expansion valves, but all work based on the same principle. Based on this principle, output of the expansion valve depends on the temperature and pressure of the evaporator output. In some older designs, you can see a capillary tube on top of this component, and this tube on the other end is connected to the output pipe of the evaporator, and this design senses the temperature of the evaporator output, and this temperature adjusts the pressure inside the chamber in the valve cap, and pressure change of this chamber moves a pin that is in contact with the diaphragm of this chamber, and movement of this pin regulates the size of a passage that is considered as the entrance of the evaporator. But modern valves don't have this tube on the outside, but the evaporator output passes through the valve and adjusts the size of the outlet for the expansion valve. Now I want to talk about another design for mobile AC systems that is less common, but maybe your car's AC system is based on that. Overall function of that system is the same with this system, but the only difference is about filter dryer and the expansion valve. In this design, a filter dryer is not used, but after the evaporator, we have an accumulator that receives output of the evaporator and gives out only gaseous refrigerant, because liquid refrigerant can damage the compressor. And also the expansion valve is replaced with an orifice tube that its hole size is always fixed, so the output of the evaporator only relies on the cycling of the compressor clutch. And finally, the evaporator, that, as the name implies, its job is to evaporate the low pressure liquid refrigerant that comes out of the expansion valve, and this component is not visible from outside because it is located inside of your car's dash. At least 3 air channels are connected to the chamber that the evaporator is located in. One is for the input air from the AC fan, and the 2 others are the outputs, and they are separated from each other using a damper. One of these output channels guides the air to pass over the heat exchanger to make the air warm in cold conditions, and one channel bypasses the heat exchanger so the heating system doesn't affect the output air of the AC system. Also, before the AC fan, there is a damper that makes it possible for the system to change source of the input air from the fresh air of the outside to the used air of the inside, or vice versa. By selecting recirculation mode, the door moves from the outside source to the inside. Modern cars can adjust and mix these 2 sources for greater comfort and windshield defrosting. Please note that if you want maximum cooling in hot outside conditions, you should select recirculation mode. Now I want to talk about more technical issues like controlling air conditioning systems and their logics. I know that some guys don't like to watch these technicalities, but I have tried my best to make a simple presentation that won't make you bored and exhausted. So please stay on and keep watching. There are two types of controlling air conditioning systems, manual and automatic. And of course, in transition from fully manual to fully automatic systems, there are some types that are called them semi-automatic systems. And I think if I can explain manual and automatic systems in perfect, I can sum up the semi-automatic types in a few sentences. In manual systems, you can adjust temperature, humidity, and air flow rate by turning on the AC system and adjusting blower fan speed and changing modes. But in the automatic systems, you only need to turn on the AC system and set in temperature, and a computer manages the remainings for you. So look at your car's AC panel, and if it has the provision for setting temperature, your car's AC system is automatic type. And also in manual systems, guiding the air and opening and closing the dampers is done by cables or maybe actuators, but in the automatic types, this opening and closing is done via electrical commands and servo motors and actuators. Now, if I divide the whole system into two sections of under the dash and under the hood, I think you know the details of under the dash for manual systems if you have watched this video up to this second. Only things that I want to add here are AC on button and blower fan speed selector that are part of the electrical power for compressor clutch and condenser fan. And it means that by commanding AC system to switch on and selecting a blower fan speed, compressor clutch, condenser fan, and under the dash blower fan will switch on. But to understand the function of these components and switches, you should get familiar with controlling circuit of your car's AC system. But before I start to talk about circuits, I want to make a key statement. Generally, we can say that manual systems use pressure and temperature switches on their controlling circuits, but the automatic types use sensors to sense the pressure and temperature of lines and components and report that to a computer, and that computer regulates compressor and fans that results in desired output. And also consider that the automatic types also use pressure safety switch on the lines or a pressure safety valve on the compressor to protect the system in the case that controlling system doesn't accomplish its mission. Now, as I said, manual systems use switches on their controlling circuits, and they connect or disconnect electrical power for compressor clutch and condenser fan. Some of these switches are controlling switches and some are safety ones. Controlling switches like AC on button and blower fan speed selector on your car's AC panel, and another controlling switch is thermostatic switch on the evaporator that senses the temperature of the evaporator and protects that against getting frozen and iced up, and if this situation happens, it opens the electrical circuit for compressor clutch until the evaporator gets unfrozen and its temperature is back to about 30 degrees Fahrenheit. Also, on the lines, there are some pressure switches that protect the system against going the pressure more than the safe operating pressure of the system or dropping very low, as this very low pressure can be caused by a low refrigerant flow in the system that can be detrimental to compressor. For this purpose, designers use 2 or 3 pressure switches on high and low pressure lines, or they use a single multi-pressure switch on high pressure line that on some models, mid pressure of this multi-pressure switch activates high speed operation of condenser fan. Now I think you can understand overall function of controlling circuit for a simple manual AC system. In brief, I can say that electrical power for compressor clutch flows from battery and goes into a few fuses and relays and then passes through some switches that are laid in series configuration in controlling circuit to protect the system. These switches are AC on button, blower fan speed selector, thermostatic switch on the evaporator, and pressure switch on high and low pressure lines and components. Now I want to talk about fully automatic air conditioning systems. As I said, in the automatic systems, the switches are replaced with sensors, and only thing that you need to do is turning on the AC system and setting a temperature. But these systems, based on design, require some additional sensors to evaluate comfort condition of individuals that are sitting in the car. These sensors provide information about outside condition, heat load of the sunlight, temperature and humidity of different zones of interior, and also amount of particles and impurities in incoming fresh air. Also, these systems have an exclusive ECU that works on a network to receive information about engine coolant temperature, engine speed, vehicle speed, and also receiving commands from some remotes that are sent to activate the AC system before the driver comes to the car, and also receiving digitized voice commands that are processed by the body control module to activate and regulate the AC system by the driver. And on the other hand, the ECU controls and commands components like blower fan and servo motors and actuators for dampers to provide and guided condition air to different zones of interior based on their demand, and also regulating compressor to optimize energy consumption and regulating condenser fan for optimum heat dissipation. And however, may there be more sensors and components for some designs, but I don't want to confuse you with more technicalities, and I think now you can understand overall function of these fully automatic air conditioning systems. For semi-automatic systems, some of the components and sensors are the same with fully automatic systems, but these systems always depend on occupants' commands to adjust the blower and changing modes that results in desired output. Also, in these systems, ECU monitors the whole system and controls relays, compressor, and condenser fan. Now, I think if you understand component, cycle, and controlling circuit of the AC systems, we can talk about some preliminary diagnosis that you as an owner can make, and don't waste your time based on wrong conception and decisions when there's a fault with that system. But please note that these diagnoses are just preliminary, and never try to fix any component, line, or electrical circuit based on that, because these actions can result in your property or body damage. And the only purpose is that you have a right conception to have a right approach when you encounter a problem. And also note that when I talk about each problem and fault, I talk about that in general. So your car's system can be manual, semi-automatic, or fully automatic type. So you need to approach to each system based on system operation and principles that I have explained for that. One of the major problems with AC systems is no or insufficient cooling. This problem can be caused by many issues. It can be a blockage for refrigerant flow, the damper for heat exchanger is stuck open, not sufficient refrigerant in the system, the condenser fan is not functioning, or dirt is accumulated on the radiator or heat exchanger or the condenser, the compressor is not engaging or is faulty. That can have many reasons, like AC fuse is blown, AC switch on AC panel is faulty, evaporator temperature sensing is in trouble, refrigerant pressure sensing is faulty, or overpressure lines are sensed, AC ECU is culprit, magnetic clutch needs to be changed, wiring harness and electrical circuit is not sound, and even drive belt can be missed. Next problem with AC systems is periodic cooling. This problem can be caused by excessive moisture in the system that ends up in forming ice in the expansion valve and its blockage, and periodic melting and forming the ice again causes periodic cooling. And because the evaporator is cold, condensation of moisture on that forms water droplets that need to be drained. So there is a drain hose under the evaporator chamber that, if it gets clogged, causes excessive frosting on the evaporator. That long periodic melting and forming the frost again on the evaporator causes periodic low and high airflow rate of the blower. And also another problem with AC systems is output of the system has unpleasant odors. This problem can be caused by funguses and bacteria that are living on the evaporator, or your car's cabin filter needs to be changed. And also, semi-automatic and fully automatic air conditioning systems have the possibility of recording trouble codes. So if you saw that AC light on your car's panel is flashing, you need to visit the service shop to read the codes and do the related repairs. Now, even though you are not supposed to do any repairs or services on your car's system, but here I want to give you some technical tips that can help you to have a fairly good idea that what technicians usually do to service and repair your car's system. First thing that a technician should do when you visit them for a fault is verifying that fault. Then they usually do a visual inspection to find any obvious fault, like a missed drive belt, non-functioning compressor, blown fuses, touching pipes and components to have a sense of the condition of the whole system, as blockage in the system causes a hot line before that and a cool line after that. And also they look for any sign of leakage on the connections and fittings and seals of the compressor input shaft that the pulley is installed on that. Now, regarding signs of the leakage, I think you need to know a very important technical issue, and it is the oil that is working inside the whole system. An AC compressor, like any other functioning component, needs lubrication, and this lubrication is partly done by the refrigerant that is working inside the whole system, but surely the compressor seizes without some amount of oil in that. AC systems working with R134A refrigerant use polyalkylene glycol or PAG oil, that is a synthetic lubricant that is very hygroscopic, and it means that it absorbs the moisture easily, and if this situation happens, it loses its desired properties. Because these oils get easily mixed with refrigerant, they flow into the whole system and lubricate O-rings and seals and keep them pliable and effective for preventing leakage. About 50% of all the oil in the system is contained in the compressor, but also other components have their share too. But during visual inspection, a visible oil leak is a sign of refrigerant leakage. Now back to that diagnostic procedure. Usually technicians take their next steps based on these visual inspections. For example, if they diagnose that the compressor is not functioning, they start to check the electrical circuit and its components like relays, wiring harnesses, and verifying for a good ground for compressor. And also they can use pressure gauge to read the pressure of the high and low pressure lines, and based on that make reasoning. Also, using diagnostic tools and reading codes and activating and deactivating components can help them to pinpoint the culprit. Now, if technicians diagnose that leakage is the cause of the problem, they can find that leaking point different ways, like using simple soap and water solution, hiss detecting microphones, or using electronic leak detectors that can find presence of refrigerant in the sampled air. And then they recover the remaining refrigerant from the system and fix the leakage or change components. And at the end, and before they recharge the system with refrigerant, they use a manual or automatic recharge machine, and after verifying for the fix, they apply a vacuum to the system for about 20 to 30 minutes, and then they recharge the system with refrigerant according to the specifications that are marked on the related under the hood label. And finally, some tips and precautions for using air conditioning systems. I have seen that some guys turn on the AC system just after sitting in the car and turning on the engine. Please note that when your car has been parked for a long time under the sunlight, likely the interior is humid and filled with harmful vapors of different materials. This high humidity demands more cooling from your car's AC system for condensation, and also harmful vapors are bad for your health. So first, try to open the windows and turn on the blower fan and let the engine to heat up a little, and then in low to moderate engine speeds turn on the AC system, because high engine speeds can be detrimental to compressor when it starts up. And next tip is that even in cold seasons, try to turn on the AC system at least twice per month, and each time for more than 5 minutes, so the oil in the system flows into the whole system and lubricates O-rings and seals so they can retain their sealing properties. And also, before you turn off the whole AC system, try to turn off the AC compressor and let the blower fan to dry out the evaporator so funguses and bacteria don't germinate on that. And also, under the hood, never try to check for refrigerant in the system by pricking on shredded valves, as this action won't give you any useful information and only you can damage your eyes or frostbite your fingers. And also remember that releasing refrigerants like R12 and even R134A into the atmosphere is illegal, and these gases need to be recollected and recycled by a qualified technician using special tools and equipment. And if you have a hybrid or electrical type car, be cautious about those compressors, that those orange high voltage cables are attached to them, because they are very dangerous even when the car is off. And also remember that keeping the AC system open to atmosphere for more than 10 minutes can make the dryer bottle saturated and useless. So it's highly recommended that you change the filter dryer each time a main component of AC system like a compressor is changed on your car. And also just know that some service shops use some dyes to find the leaking point, and also there are some stop leak sealants in the market that using these products and applying them excessively can cause blockage and other mechanical and chemical damage to the whole system. So try to stay away from these products. And finally, please note that due to normal refrigerant leakage, it's normal that your car's system loses its effectiveness after about 3 years. But there are some systems that work without any problem, even after 10 years without recharging. I hope that this video was useful and informative for you and worth the precious time that you spent for watching that. Please subscribe to my channel if you like and press the bell icon to be notified if I have a new video on my channel. Bye.